Okay, today we're going to apply the angle, side, angle, angle, side, and hypotenuse leg to construct triangles and to solve problems. We're also going to prove triangles that should say congruent by using the angle, side, angle, angle, side, and hypotenuse leg. The included side is the common side of two consecutive angles in a polygon. Okay, so if we have angle P and angle Q, the included side is the side that they share, which is side or segment PQ. Okay, so if we were going to use angle R and angle Q, what would be the included side? This side right here. Angle, side, angle postulate. If two angles in the included side of one triangle are congruent to two angles in the included side of another triangle, then the triangles are congruent. So what this says is angle A is congruent to angle D, angle C is congruent to angle F, the included side AC is congruent to the included side DF, so you can say that these triangles are congruent. So let's prove it. Determine if you can use angle, side, angle to prove the triangle's congruent and explain. Okay, we've got this angle and this angle congruent, this angle and this angle congruent. So we've got two angles congruent. And we've got this side right here congruent because of the reflexive property. So can we use angle, side, angle? No. Why? Because in order to use angle, side, angle, the side has to be included. It must be this side here and this side here. So you cannot use angle, side, angle because you're not including the included side. Determine if you can use angle, side, angle to prove these two triangles congruent. Okay, so let's see here. We've got parallel lines. So what does that tell us? That tells us that angle KLN is congruent to angle MNL. Why do we know they're congruent? Because they're alternate interior angles. Okay, we also know that angle KNL is congruent to angle MLN. So we've got this angle and this angle, Y, AIA. We also know that segment LN is congruent to segment NL. I've got LN, I've got NL, Y. Reflexive property. The side is this side right here. It is included, that is the included side. So we can write our congruency statement and say that these triangles are congruent because of angle, side, angle. Angle, angle, side. If two angles and a non-included side of one triangle are congruent to the corresponding angles and not including side of the other triangle, then the triangles are congruent. So what we have is we have angle G and J congruent to angle K and M. And the corresponding non-included side, HJ, corresponds with LM, and they are congruent. This is your angle side. So let's use this. Okay, I'm going to write a proof here. Let's start with what's given. So we have angle YZW congruent to angle YWZ. That is given. YZW, this angle, is congruent to YWZ. YWZ, this angle. XY is congruent to VY. This is given. XY is congruent to VY. Okay. Okay. Let's see, what are we trying to prove here? We're trying to prove XYZ, this triangle, congruent to VYW. VYW, this triangle. Okay, so we've got one segment so far that's congruent. So let's look at these angles right here. This one and this one. Angle XZY, XZY, and angle YZW, YZW are what type of angles? They're a linear pair, right? So, VWY, angle VWY, this angle right here, is going to be linear pair with YWZ. Same thing. So what we can say is angle YZX, angle YZX, YZX is congruent to angle YWV, YWV. This is your supplementary congruence theorem. Okay, and then let's go with what's given. Angle X is congruent to angle V. That is given. Okay, so let's see what we have here. We've got a side, we've got YZX, YZX, this angle, congruent to YWZ, YWZ. Wait a minute, that's not right. It's YWV. This right here is an error. That should be a V. We're saying these angles here are congruent. Okay? Because if this is a linear pair and this is a linear pair, this angle and this angle is congruent, you can say that these two angles are congruent because of your supplementary congruency theorem. All right? So we have a side, we have an angle. We also have angle X, which is, let's use blue, this angle, congruent to angle V, this angle, because it's given. So we have angle, angle, side, angle, angle, side. So triangle XYZ is congruent to triangle VYW because of angle, angle, side. All right, last one. I'm going to be quiet, see if y'all can do this one on your own.